my project was basically based on buoyancy, which is like the tendency of an object to float or sink in a fluid. My question was, how does density affect buoyancy? My hypothesis was that denser objects would experience greater buoyancy than less dense ones. And you can see my materials listed here. And my procedure was determining the volume of objects like a cube. You would do length times width times height, and the formulas for a cylinder and sphere are shown here. And there's determining the density. After that, it was density divided by, mass divided by volume would equal density. And then I would determine the water displaced by objects, and then after that I determined the buoyant force. And here you can see my results. This was like the densities of different objects, and here it shows the buoyant property of objects in the water, like positively buoyant, which means floats up all the way, and neutrally buoyant, which means kind of submerged, and negatively buoyant, which means completely sunk. And here it shows the water displaced by the tube and the objects. The objects in the tubes and all that. And here are a few pictures of them. And here it shows the comparison between the density of the objects and the volume of water displaced. And here it shows the linearity of those density versus the buoyant force relationship. And I want to come back to this thing. I did a side experiment. It was the effect of water density on the buoyancy of like an egg. And I saw that when I put the egg in the water, it sunk all the way, but when I put the salt solution into the water, the egg started to float. And a few conclusions are here. A simple approach was taken to establish a relation between density and buoyant force using water. And the use of water as the study fluid kept the calculation simple because there's no change in the variable. And my experiments identified positive, neutral, and negative buoyant objects. And the results on the buoyant positive and buoyant neutral objects were confirmed by the Archimedes principle, which is back up there. And the buoyancy is affected by density of the fluid as well as that of the objects. If the fluid density is greater than the density of the object floats. If less, the object sinks. Figures 1 and 2 is up here somewhere. And a linear relationship exists between the buoyancy and density of objects, which is shown up here. And my last conclusion was that denser objects experienced higher buoyant force, table 2 and figure 5, and so my hypothesis was correct.